Please find a comfortable position. Sit or lie down. Let every part of your body slowly relax. Gently close your eyes. Set aside the distractions and thoughts of the day for now. Now please focus your attention on my voice. Let us embark on a tranquil journey through the stars together. Billions of years before human civilization emerged, the universe already existed and operated according to its inherent laws. Those twinkling stars and silent nebulae form the most grand and serene backdrop we can perceive. Tonight I will use a calm voice to tell you about some real scientific events that occurred in our universe in 2025. There are no thrilling speculations here, only rational descriptions based on observational facts and humanity's eternal curiosity about the boundless void of space. You can use this knowledge as background for your thoughts, allowing your mind to wander freely among the stars. Now follow your breath. As you inhale, feel the vastness of the universe. As you exhale, release the fatigue of body and mind. We will begin with a visitor from afar, slowly entering a state of learning and relaxation. On July 1st, 2025, the Asteroid Terrestrial Impact Last Alert System telescope in Hawaii was scanning the night sky as usual. Its program captured a previously unrecorded point of light in the direction of the constellation Cancer. This point of light was very faint, with an apparent magnitude of only 195, far below the limit of direct human visual observation. Astronomers quickly mobilized other telescopes worldwide for follow-up observations. They needed to calculate the orbit of this new celestial body. To determine its origin, when the orbital data was precisely calculated, a wave of excited ripples spread through the scientific community. The results showed this object had a hyperbolic orbit. This meant it possessed kinetic energy exceeding the solar system's escape velocity. It was not a native object orbiting the sun, but a passerby from beyond our solar system. According to the International Astronomical Union naming conventions, it was officially designated 3I Atlas. 3I signifies the third confirmed interstellar object. Atlas is the name of the telescope system that discovered it. Before this, we had only confirmed 2 interstellar visitors. The first was Oumuamua, discovered in 2017, meaning scout from the distant past in Hawaiian. Oumuamua's shape was inferred to be extremely elongated, its length possibly 10 times its width, unlike any known. The second was Comet Borisov, discovered in 2019. It behaved more traditionally with a clear coma and tail. Its composition and behavior were quite similar to comets in our solar system. The arrival of 3I Atlas provided us with a new sample to study the composition of exoplanetary systems. Each such interstellar visitor is like a message in a bottle, containing information about its birth system. By analyzing their spectra and dust, we gain glimpses into the chemical composition and physical environments of distant star systems. This is an invaluable practice for astronomical archaeology. As telescopes worldwide focused on 3I Atlas, a series of unusual characteristics began to emerge. The first to catch astronomers' attention was its mass and brightness. Initial estimates based on reflected sunlight suggested a diameter between 10 and 20 kilometers. This size far exceeded the previously discovered Oumuamua and Comet Borisov. Statistically, such a large interstellar object should be extremely rare. However, subsequent observations presented an even greater puzzle by analyzing its trajectory's response to gravity. Scientists found that despite ejecting hundreds of kilograms of material per second, its orbit showed almost no non-gravitational perturbations. This indicated an extremely dense core and tremendous total mass. Latest estimates suggest a mass possibly exceeding 33 billion tons. For an object about 5 kilometers in diameter to have such mass, hints that its interior may contain large amounts of non-volatile dense material. Perhaps rock, perhaps metal. This contrasts sharply with its comet-like appearance. Another striking discovery came from spectral analysis. The Very Large Telescope in Chile, using its UV and visible light spectrograph, conducted detailed observations between August and September 2025. Data revealed significant amounts of nickel atoms in its coma gas, and the nickel abundance increased sharply as it approached the sun. But in stark contrast, almost no iron was detected. In natural minerals, nickel and iron are usually found together. They are produced in stellar nucleosynthesis and supernova explosions. In all known solar, the nickel-to-iron ratio remains within a relatively stable range. The nickel-iron separation, exhibited by 3I Atlas, on Earth is typically associated with industrial smelting processes. How this separation occurs under natural conditions in space is a significant challenge for current astrochemistry. Scientists have proposed some hypotheses. For example, unknown low-temperature chemical processes within it, or special structures of its dust grains, selectively releasing nickel during sublimation. But these hypotheses require more data for verification. Furthermore, high-resolution images from the Hubble Space Telescope in July revealed another anomaly. The scattered light in its coma extended farther towards the sun. This defies the common knowledge that comet tails always point away from solar radiation pressure. Professor Avi Loeb from Harvard and Dr. Eric Tito collaborated on a theoretical model. They suggested that if the object ejected ice fragments of specific sizes from its sun-facing side, fragments large enough that radiation pressure couldn't quickly push them away, it might create this sunward extension. The model is physically valid, but the conditions it requires are very specific, never before so clearly observed in natural comets. All these anomalous properties make 3I Atlas a unique object of study. It may represent a completely new class of interstellar object, whose formation mechanism and evolutionary history could be fundamentally different from any object in our solar system. The trajectory of 3I Atlas itself is also full of noteworthy characteristics. Its orbit aligns almost perfectly with the solar system's ecliptic plane, with an inclination of less than 5 degrees. From a probabilistic standpoint, the chance of a randomly entering interstellar object having such alignment is only about 2%. This special geometrical relationship allows it to make close flybys of multiple inner solar system planets in sequence. According to orbital dynamicist calculations, it would pass Venus at 065 AU, Mars at 019 AU, and Jupiter at 036. A single trajectory allowing favorable flybys of 3 planets. Such orbital design would be considered highly efficient and elegant for a probe, Of course, nature itself can occasionally create such paths through gravitational interactions, but this certainly adds a layer of mystery to 3I Atlas. Another widely discussed topic is its possible connection to the famous 1977 WOW signal. Back then, the Big Ear radio telescope at Ohio State University detected a strong narrowband signal from the direction of Sagittarius lasting 72 seconds. Its frequency was exactly the characteristic hydrogen line at 1420 megahertz. This discovery, known as the WOW signal, remains one of the most famous unsolved mysteries in SETI. When scientists traced 3I Atlas's path backwards, calculating its position in 1977, they found it was only about 9 degrees away from the WOW signal's origin. This spatial proximity has a coincidence probability of approximately 6%. Although this probability is not extremely low, the intersection in space-time of two such notable astronomical events naturally sparks endless scientific speculation. It must be emphasized that orbital dynamics is an extremely precise science. We can predict an object's position years in advance with kilometer-level accuracy. This predictive capability is built on a solid foundation of Newtonian mechanics and Einstein's relativity, and considers all known gravitational perturbations and radiation pressure effects. When 3I Atlas reemerges from behind the Sun in early December 2025, observatories worldwide will precisely measure its position. Any tiny deviation from the predicted orbit will tell us if something unusual happened during its perihelion, whether it was simple outgassing causing orbital changes or more complex physical processes. The answer lies within the forthcoming observational data. Observing 3I Atlas is fraught with challenges. The most significant event occurred on October 3, 2025, when it made its closest approach to Mars at a distance of only 29 million kilometers. This was a once-in-a-lifetime opportunity for close observation. Multiple spacecraft orbit Mars, including NASA's Mars Reconnaissance Orbiter. Its high-resolution imaging science experiment camera can resolve objects the size of a small car on the Martian surface, theoretically capable of clearly imaging 3I Atlas's nucleus. The European Space Agency's Mars Express and Trace Gas Orbiter also adjusted their attitudes for joint observations. However, during this critical period, the U.S. federal government shut down due to budget issues. 15,000 NASA employees were forced to take leave. This severely impacted the planned data analysis and release. Although the spacecraft themselves continued automatic operation and data collection, most scientists responsible for processing and analyzing this data could not work. This interference of administrative factors in scientific research highlights the dependence of basic science on stable policy support. Meanwhile, 3I Atlas's orbital position was gradually moving towards the Sun-Earth line. This phenomenon is known astronomically as solar conjunction. From Earth's perspective, it seemed swallowed by the Sun's intense glare. From November to December 2025, it would be completely hidden behind the Sun. No telescope on Earth could observe it. This observational gap is both a challenge and an opportunity. The European Space Agency's Jupiter Icy Moons Explorer, positioned en route to Jupiter, will turn towards 3I Atlas in early November, attempting observations just after its perihelion uses cameras and spectrometers, though designed for icy moons, are also suitable for comet-like objects. It will provide a viewing perspective different from Earth's, potentially capturing features we cannot see from here. Astronomers worldwide are coordinating, planning observation schedules for its early December reappearance, from Chile's Atacama Desert to Hawaii's Mauna Kea. From the Hubble Space Telescope in orbit to the Very Large Telescope Array on the ground, all are prepared for this moment. This global scientific collaboration embodies human unity and wisdom in facing cosmic mysteries. Every data point will be carefully analyzed. Every image will be repeatedly studied. This is how science advances step by step, unraveling nature's puzzles through collective intelligence. While our gaze focuses on distant interstellar visitors, the monitoring of the inner solar system environment continues. On October 1st, 2025, an asteroid named 2025 TF approached Earth without warning. Its closest approach was only 419 kilometers above the Earth's surface. This altitude is lower than the International Space Station's orbit. It was discovered by Arizona's Catalina Sky Survey 6 hours and 36 minutes after its closest approach. This post-flyby discovery is not unprecedented in astronomy, but each occurrence reminds us of the importance of NEO-monitoring. 2025 TF has a diameter between 12 and 27 meters. It traveled at 209 kilometers per second, fast enough to cross the continental U.S. in under 4 minutes. Had it collided with Earth, it would have disintegrated and exploded in the upper atmosphere, releasing energy equivalent to thousands of tons of TNT, while not causing a global catastrophe. It could have caused local damage. Its orbital parameters show an elliptical path, semi-major axis of 162, O perihelion at 0676 AU, aphelion at 256 astronomical units, orbital inclination of 91 degrees. With observational data based on just a one-day arc, its orbit is classified as poorly constrained. Condition Code 7. This means our predictions of its future path have high uncertainty. It might return and pose a threat, or it might leave the inner solar system forever. This situation highlights the limitations of our monitoring capabilities. Our current telescope network primarily targets larger NEOs, those over 140 meters capable of causing regional devastation. For smaller objects like 2025 TF, they are numerous and difficult to detect. Until they are very close, NASA's NEO observation program and the upcoming Vera C. Rubin Observatory are expected to significantly improve our discovery and tracking of these small objects. The Rubin Observatory, during its first 10 hours of trial operation, discovered 2,104 new objects, demonstrating its revolutionary survey capability. With these new facilities coming online, we will be able to more comprehensively map the inner solar system's dynamic picture, better protecting our planet from potential impact threats. Millions of kilometers away in Mars's U-0 crater, another exciting scientific story is unfolding. NASA's Perseverance rover on JULY-2424 drilled into a rock sample shaped like an arrowhead. This rock, named Chiawa Falls, is covered in peculiar patterns scientists call leopard spots. These spots are circular features with light centers surrounded by dark rings. On Earth, similar patterns are often associated with microbial activity. Two advanced instruments on Perseverance conducted detailed analysis of these spots. The Sherlock instrument detected strong organic carbon signals, known as the G-band spectral feature. The PIXL instrument mapped the elemental distribution across the rock surface. Analysis revealed these spots contain two special minerals, vivianite, a hydrated iron phosphate, typically forms in sedimentary environments with organic matter present. Grayite and iron sulfide is a byproduct of certain microbial metabolic processes. The coexistence of these two minerals with organic carbon at the microscopic scale constitutes a potential biosignature. Notably, Chiawe Falls is located in a geological formation called Bright Angel, along the edge of Neretva Vallis. Over 3 billion years ago, this was a wide river channeling water into Jezero crater. The mudstones and layered sedimentary rocks of Bright Angel record a dynamic environment with periods of fast-flowing river water. This is precisely the kind of environment where microbes thrive on Earth. This discovery is surprising because Bright Angel represents some of the youngest sedimentary rocks the Perseverance mission has investigated. Previously, scientists thought signs of Martian life would exist in older rocks. Finding potential life signs in this relatively young rock suggests Mars may have remained habitable longer than imagined, or that life persisted longer into Martian history. However, science requires extreme rigor. Project scientist Katie Stack Morgan emphasized. Astrobiological claims, especially involving past extraterrestrial life, require extraordinary standards of evidence. Therefore, the research team submitted their data and conclusions to Nature magazine for peer review. External scientists spent an entire year scrutinizing every step of the analysis, seeking possibilities of non-biological processes forming these patterns, while some possible abiotic explanations were found. None fit all the data as perfectly as the biogenic hypothesis. To ultimately confirm whether these features truly originate from life, scientists need to bring the sample back to Earth, using equipment far more precise than the rover's instruments. Laboratories can conduct isotopic analysis, study molecular structures of organic compounds, perform experiments impossible on Mars. This is the importance of the Mars Sample Return Mission. The Mars Sample Return Mission is regarded as the holy grail of planetary exploration. This joint project by NASA and the European Space Agency aims to bring the core samples collected by Perseverance back to Earth, including the precious sample from Sapphire Canyon. These samples are sealed in ultra-clean titanium tubes, currently resting on the Martian surface, awaiting future retrieval missions. The scientific value of sample return is immeasurable. Earth laboratories can use electron microscopes, synchrotron accelerators, secondary ion mass spectrometers, and other large equipment for nanoscale analysis. These analyzers can detect molecular chirality, measure isotopic ratio anomalies, search for possible microbial fossil structures. These are definitive experiments impossible on Mars. However, this grand plan faces serious challenges. The project budget has severely overrun from an initial $4 billion. soaring to potentially over $11 billion. The timeline has also been repeatedly delayed, from the original 2030 return date pushed back to no earlier than 2040. The U.S. President's proposed FY 2026 budget suggests completely canceling the current project architecture. This is caused throughout the planetary science community. At the press conference announcing the Chihuahua Falls discovery, Acting Administrator Sean Duffy stated, "This is not abandoning the sample return goal, but pivoting towards seeking cheaper, faster alternatives. Possible options include simplifying the mission architecture, using commercial company landers, or deeper cooperation with international partners." Meanwhile, China's Tianwen-3 mission plans to launch in 2028 to execute a Mars sample return. If U.S. plans continue to be delayed, China might become the first to bring Martian samples back to Earth. Behind this quiet competition is a comprehensive of deep space exploration capabilities, including heavy-lift rockets, precision landing technology, Mars surface ascent, orbital rendezvous and docking, high-speed Earth re-entry, and other key. Whichever nation achieves this first will open a new chapter in Martian history for all humanity, answering the ultimate question of whether we are alone in the universe. The close flyby of asteroid 2025 TF once again reminds us of the urgency of establishing a comprehensive NEO monitoring and defense system. Current global monitoring networks mainly consist of ground-based optical telescopes and radar systems, including the U.S. Catalina Sky Survey, Pan-STARRS, and the upcoming Vera C. Rubin Observatory. These systems continuously scan the night sky, discovering and tracking potentially Earth-threatening objects. For objects over 140 meters in diameter, our discovery rate exceeds 90%. But for smaller objects like 2025 TF, the monitoring network still has significant blind spots in terms of defense technology. NASA's DART mission has already proven that changing an asteroid's orbit via kinetic impact, the mission successfully shortened the orbit period of asteroid Dimorphos by 33 minutes. Future possible defense solutions also include gravity tractors, laser ablation, nuclear deflection, and other technologies, each with its own advantages, disadvantages, and applicable scenarios. The European Space Agency's planned Hera mission, in collaboration with NASA, will conduct detailed reconnaissance of the binary asteroid system, Didymos, providing more foundational data for planetary defense. Establishing a comprehensive NEO monitoring and defense system requires joint efforts from nations worldwide, including sharing observational data, coordinating research resources, conducting joint mission exercises. This is not just a scientific issue, but a major concern related to the safety of all humanity. Our Sun is experiencing the peak phase of its 11-year activity cycle. This cycle, averaging 11 years, from solar minimum to maximum and back to minimum, constitutes the Sun's fundamental rhythm. At solar maximum, the Sun's surface exhibits numerous sunspots. These seemingly dark regions are actually areas of intense magnetic field concentration, about 1500 degrees Celsius cooler than the surrounding photosphere, hence appearing relatively dim. When magnetic field lines in these regions reconnect, they release enormous energy, forming solar flares and coronal mass. A large flare can release energy equivalent to millions of volcanoes erupting simultaneously within minutes, while CMEs can propel billions of tons of charged particles into space at speeds of millions of kilometers per hour. Interestingly, solar maximum does not mean immediate weakening of auroral activity. Solar physicist Paul Breck at the Norwegian Space Agency noted, "Peak auroral activity typically occurs a few years after solar maximum. This is because during the solar declining phase, long-lived coronal holes become the main source of high-speed solar wind, continuously affecting Earth's magnetosphere. We are in such a period now. The next few years might see more intense auroral displays." Aurorae are direct manifestations of the interaction between the solar wind and Earth's magnetic field. When charged particles from the Sun reach Earth, they are guided by Earth's magnetic field, converging towards the polar regions. These particles collide with oxygen and nitrogen atoms in the upper atmosphere, exciting them to emit light at specific wavelengths. Oxygen atoms primarily produce green and red light. Nitrogen atoms contribute blue and purple hues. Scientists use the KP index to quantify geomagnetic activity intensity. This index ranges from 0 to 9, divided into 5 levels. A G1 level storm might only produce faint aurorae in polar regions, while a G5 level superstorm could make aurorae visible at the equator. In early October 2025, Earth experienced 5 consecutive days of geomagnetic activity. Solar wind speed reached 768 kilometers per second, although gradually declining to 608 kilometers per second. It was still sufficient to trigger G1 level geomagnetic storms in Iceland, Norway, Canada, and the northern United States. People captured spectacular images of dancing green, pink, and purple aurorae. Aurorae are not only beautiful natural phenomena, they can also impact modern technological systems. Intense magnetic storms can disrupt radio communications, affect GPS positioning accuracy, cause satellite orbital decay, and in extreme cases threaten power grid security. The Great Magnetic Storm of March 1989 caused a province-wide blackout in Quebec, Canada, for 9 hours. Therefore, accurately predicting space weather is as important as predicting terrestrial weather. The October 2025 sky is unusually lively. 3 green comets appear simultaneously in our view: Comet Lemon, Comet Swan, and Comet Atlas. Their coincidental emerald hues stem from the same physical mechanism: fluorescence emitted by diatomic carbon molecules after absorbing solar ultraviolet radiation. Comet Lemon is the brightest among them. Discovered on January 3, 2025 by Arizona's Mount Lemmon Observatory. Initially, it was just a faint 215 magnitude object. Astronomers even doubted if it was true, but after emerging from the sun's glare in August, it began rapidly brightening, reaching magnitude 66 by late September. Latest predictions suggest, at its closest approach to Earth on October 21st, it might reach magnitude 3 or even 4. At dark observation sites, the naked eye might perceive a fuzzy patch. Comet SWAN's discovery was more dramatic. It was spotted just 1 day before reaching perihelion by sharp-eyed amateur astronomers. and images from the C1 instrument aboard NASA's Solar and Heliospheric Observatory. Although it is now dimming as it moves away from the Sun, on October 20th at its closest approach to Earth, it will pass close to Mars in the sky, offering a fantastic photographic opportunity for astrophotographers. The faintest comet, Atlas, is steadily brightening, will reach its best viewing in the coming weeks. These comets all follow extremely elongated orbits. Comet Lemon's orbital period might be as long as 1350 years. We are witnessing the most glorious moments of their lives. The unpredictability of comet behavior makes them the most anticipated objects in the night sky. They might suddenly brighten or fade away silently. This uncertainty is precisely the charm of astronomical observation. Starship represents SpaceX's complete reimagining of space transportation. This 120-meter-tall behemoth is not only the most powerful rocket ever built, but a fully reusable transportation system. Its design goal is to reduce the cost of reaching space by 2 orders of magnitude, thereby opening a new era of space exploration. On October 13th, 2025, Starship conducted its 11th flight test. This mission carried a special purpose. It would be the final flight for the second-generation Starship. All subsequent versions would be fully upgraded to the third-generation design. The success of the 10th flight provided a boost of confidence for the entire project. During that mission, the Super Heavy booster splashed down as planned. The upper stage spacecraft, after completing its suborbital flight, successfully re-entered the atmosphere and achieved a controlled splashdown in the Indian Ocean. It also completed a Starlink satellite deployment test during flight, proving its capability for operational use. The 11th flight went a step further, using flight-proven hardware. Booster B-15 had been successfully caught by the launch tower's mechanical arms during the 8th mission. This time it was equipped with 24 flight-proven Raptor engines. The mission profile seemed similar to the previous one, but was filled with technical innovations in the details. The booster tested a completely new landing burn sequence, igniting 13 engines to begin deceleration, then transitioning to 5 engines for the divert maneuver, finally using the central 3 engines to complete the landing. This multi-stage variable thrust landing scheme aimed to gather data for the more powerful third-generation booster. The upper stage spacecraft's tests were even bolder. Engineers intentionally removed some heat shield tiles, allowing re-entry plasma to directly scour these areas. This seemingly risky approach actually aimed to identify weak points in the protection system, understanding the conditions the spacecraft could withstand. If the spacecraft survived, it would also test autonomous navigation algorithms during the subsonic phase, preparing for future landings back at the launch site. The entire space community watched this test closely, because Starship is not only core to SpaceX, but was also selected by NASA as the human landing system for the Artemis program. Its success or failure directly relates to the U.S. return to the Moon timeline. While U.S. commercial space advances rapidly, China's deep space exploration program progresses steadily at its own pace. On May 28, 2025, a Long March 3B rocket lifted off from the Zhejiang Satellite Launch Center, sending the Tianwen-2 probe into its planned orbit. This mission's target is very unique. Asteroid 2016HR3, also known as Kamoa-Leia. This is a special near-Earth object. It maintains a peculiar orbital resonance with Earth. From Earth's perspective, it appears to orbit us, though it actually orbits the Sun like Earth does. Spectral observations show its surface composition resembles space-weathered lunar rock. This leads to an interesting hypothesis. It might be a fragment ejected from the lunar surface by a giant impact billions of years ago. Tianwen-2's mission is to verify this hypothesis. After a year's journey, the probe will reach its target in 2026, then spend a year conducting detailed mapping. This asteroid is only 40 to 100 meters in diameter, but rotates once every 28 minutes, making sampling extremely challenging. Chinese engineers prepared 3 sampling methods, including hover sampling, touch-and-go sampling, and drill anchor sampling, planning to collect at least 100 grams of sample for return to Earth around 2028. The most exciting part begins after sample return. The probe will use Earth's gravity assist to fly towards its next target, Main Belt Comet 311P Pan-STARRS, expected arrival in the mid-2030s. This 2 targets with 1 probe mission planning demonstrates the ambition and wisdom of China's deep space exploration. On the other side of the U.S. spaceports, NASA faces unprecedented challenges. The October 1st, 2025 government shutdown forced 15,000 employees into indefinite leave. Only 3,000 essential personnel remained at their posts. They maintained basic International Space Station operations, ensuring astronaut safety, processing over 1,000 commands daily, uncertain when they would receive paychecks. The Artemis program continued due to its national security designation, but this couldn't the agency's systemic crisis. Even before the shutdown, NASA had begun large-scale layoffs. The management office demanded cutting over 4,000 positions. Many senior engineers and scientists opted for early retirement, including the lead expert for the Lunar Nuclear Reactor Power System. Such losses might take decades to recover from. The President's proposed FY 2026 budget suggested cutting NASA funding to its lowest level since 1961. Considering inflation, this budget was even lower than during the first crewed spaceflight era. Most heartbreakingly, the budget proposed canceling 41 missions already underway, including the nearly ready Nancy Grace Romang Space Telescope, the OSIRIS-APEX probe en route to asteroid Apophis, and the highly anticipated Mars sample return mission. Some projects had already cost billions. Others were on the verge of major discoveries, now faced premature termination. Even venerable missions like the Chandra X-ray Observatory and Hubble Space Telescope might see their missions ended early due to budget cuts. These short-sighted decisions are eroding U.S. leadership in space and damaging trust with international partners. The European Space Agency has expressed serious concern over the Mars sample return mission. At Johns Hopkins University, astrophysicist Dr. Stephen McCann articulated the academic community's sentiment. They had to apply to the university for emergency funding just to maintain basic research activities. Less resourced institutions might never recover from this blow. On September 9, 2025, The U.S. House Oversight Committee released a video dated October 3, 2024, showing a bright spherical object moving steadily against a dark background. Suddenly, a Hellfire missile enters the frame, striking the target directly. But the expected explosion doesn't occur. The object neither fragments nor deviates from its path, continuing its original trajectory. The missile appears to bounce off an invisible barrier. This video was captured off the coast of Yemen by an MQ-9 Reaper drone on patrol, protecting shipping lanes from attacks. The Department of Defense neither confirmed nor denied the video's authenticity, merely stating it could provide no information. This silence deepened public suspicion. Similar imagery is not isolated. Air Force veteran Dylan Borland testified at the hearing, describing his 2012 experience at Langley Air Force Base. A triangular craft hovered at low altitude for several minutes, then instantly accelerated to jet altitude and departed at high speed. After filing a report per procedure, he faced workplace retaliation, security clearance questioned, ultimately forced to leave his position. These cases highlight flaws in the current investigation system. The All-Domain Anomaly Resolution Office is supposed to handle such incidents, but its conclusions are often unconvincing. For example, explaining the famous 2015 Go Fast video as a weather balloon and visual illusion, contradicting the first-hand experience of the pilot witnesses. Facing these immediately unexplainable phenomena, the scientific community maintains a cautiously open attitude. The history of science tells us many once mysterious phenomena ultimately found natural explanations. Truly breakthrough discoveries often lie within carefully designed experiments and repeatable evidence. The AARO claims it uses a rigorous scientific framework for each case, analyzing UAP through data-driven methods. However, its analysis process lacks transparency. Conclusions often disregard witnesses' first-hand accounts. In the Yemen video case, some analysts suggested the object might be a high-altitude balloon. The missile didn't actually hit, just a perspective illusion. But this explanation contradicts the Hellfire missile's damage characteristics. This missile uses a kinetic impact detonation mechanism, exploding immediately upon contacting hard targets. Former senior intelligence official Luis Elizondo pointed out they had never seen a Hellfire missile bounce off a target after impact. The essence of science is maintaining skepticism, while avoiding preconceptions when evidence is insufficient. Admitting ignorance is more valuable than forced explanations. Data from the National UFO Reporting Center shows 2,000 sighting reports in the first 6 months of 2025 alone. The Pentagon received over 750 new reports in a recent one-year period. Regardless of the nature of these phenomena, their frequency is indeed increasing. This itself is a topic worthy of scientific study. As we review these astronomical events, from interstellar visitors to near-Earth asteroids, from Martian life signs to solar activity cycles, we see a universe full of vitality, yet following its laws. The peculiar properties of 3I Atlas remind us that cosmic diversity far exceeds our imagination. The chemical signatures on Martian rocks hint that life might not be alone. The sun's periodic activity manifests the life rhythm of stars, SpaceX's repeated tests, China's steady deep space exploration, NASA's perseverance amidst all constitute the magnificent tapestry of human space exploration. Now please close your eyes again. Feel the rhythm of your breath. Let this knowledge of the cosmos flow freely in your mind. Imagine floating peacefully in space, surrounded by silently moving stars, their lifetimes measured in billions of years, their laws eternal and unchanging. Against this grand backdrop, all worries seem insignificant, all conflicts turn to dust. May you carry this cosmic tranquility into your dreams. May you find deep rest under the watch of the stars. Thank you for your company tonight. Until our next journey through the stars.